Hey there, welcome to episode 124 of the Quaggling Sand audio program. I'm your host, Dan Hugo. We are recording this at 12:13 p.m. Pacific Daylight Time here in the greater Vegas area on Wednesday, March 25, 2026. Today's title and topic, Discovering PostgreSQL. We normally publish episodes of Quaggling Sand on Wednesdays, often in the morning, but not always. So today will be early afternoon. Discovering PostgreSQL. If you're not a programmer, you probably have no idea what that is, but maybe I guess if you're not a programmer, you should treat this as a sort of a general self-teaching learning adventure. I don't know if it'll make so much sense if you're not familiar at all, but there's not really a lot of technical jargon. So we'll see. If you don't listen, that's okay. There'll always be another episode. If you're not familiar with the Quaggling Sand program, though, let me tell you, you've come to the right place. Quaggling Sand is a term I coined when I was very young. You probably refer to the same thing as pins and needles. Quaggling sand is the sensation that one feels as circulation returns to, say, your hand, if you're sleeping on your hand, or if you're sitting funny on your foot and it goes numb. Well, as circulation returns, the pins and needles, or more correctly, quaggling sand sensation is felt. In this case, with this audio program, it is the swirling motion of the internal thought process as I recall and recount tales, stories, other adventures. Hopefully there'll be enough for lots more episodes. I'm still remembering everything, so that's good. Everything as far as I know. Hopefully, wherever you found this audio program, you're able to locate the episode description, which contains the show notes, including a very brief summary this week, and the links for today's episode, the usual 2+1 for what Postgres is, PostgreSQL. So on that note, let's get started so we can get finished on this lovely Wednesday. Ooh, it's a little bit cooler today. Hopefully it will stay that way. No, I think it's going to be hot. I think it's supposed to be hot until a week from now, I think it is. So another hot day here in the desert. Go figure. The summary of today's episode: between Silicon Valley tours during my respite in Phoenix. I usually say that word both ways just to cover the bases. During my respite in Phoenix, Arizona, I picked up a new skill that has been with me ever since. Quaggling Sand homepage, spelled just like it sounds, QUOGGLINGSAND.com. Someday it'll look nice. I'm not even going to comment anymore until I have reached that milestone. The profile page linking everything has been around for 5 years since I first signed up. We're only a couple days away from me not being able to say that so eloquently, but I did sign up sometime in March of 2021. The buymeacoffee.com/DanHugo profile page is sort of a free-form link tree of sorts. It enables me to share links to all of my various productions, different projects, even some affiliate links, and some biographical information about me if you're curious. And also the Buy Me an Update audio program is published first at buymeacoffee.com/DanHugo/posts. But in any case, you're not expected or required to spend any money. You can still get those links completely free. But the affiliate links, if you're interested, these are things I actually use, including some of my favorite coffee beans. Any funds that do arrive through this or the Ko-fi.com, ko-fi.com/DanHugo platforms do go towards coffee or coffee accessories, because that is what powers all of this. But yeah, no obligation to spend any money, don't worry. But you'll find links to all of my various audio programs, especially. And the link for today's episode, PostgreSQL project site, so you have some idea of what I'm talking about, postgresql.org. It's probably more for technically minded people, but if you're curious, postgresql.org, and check that out. On with the show. So I have talked about my 2 tours through Silicon Valley. I've talked about different jobs I've had in Silicon Valley. I've talked about a lot of aspects of Silicon Valley. It was it 13 or 15 years or something, which is non-trivial. It's certainly about half of my professional career since getting out of college. So it's a noteworthy interval of time. So I'm not going to harp on too much of that today, but if you are not familiar with the two tours, I moved to Silicon Valley after college. I left Silicon Valley in 2001. I had just had enough at the time. I left in August of 2001, moved back to Phoenix, and then I moved back to Silicon Valley because it turns out I had not had enough in September or October of 2005. So a 4-year break in Phoenix, back to Silicon Valley so that I could have a house fire in 2013 and move to Vegas. So I never really touched databases in that first tour, even all through college and in the first tour through Silicon Valley. I was working more with hardware, embedded microcontrollers, and of course my time in Apple QA, which was very early. My second, technically my third, but my second real job when I graduated from college and moved to Silicon Valley. So we did use a database at Apple in general. It was my first exposure to something like this, a bug database. So I didn't have anything to do with the database design. It was all the tool built on top of the database. It's called Aardvark, if you're curious. And later I would meet someone who was on the development side of that, the bug database project when I was working at Netscape, but that's another story for another time. So I had no developer knowledge of the database. I would think it was a Sybase database. So I had no insights into how it worked. Actually, as I'm writing this episode, I'm going to share something I learned in that database end user experience, which was sort of funny. This was back in the day, as in, way back when Apple was switching over from the Motorola 68000 series of processors that were in the original Macintosh to the first PowerPC, the Power Macs, which was a high-risk project to say the least. At this point, Apple changes processors every few years, so it's no big deal. The database, Sybase-based database written in Aardvark. So it had this was before the web was so ubiquitous. So there was a tool, Aardvark. It looked like a web page, but it had various user interface elements so you could control what you were searching for and a big giant forms to fill out when you found a bug or an issue. So this central database was shared by all projects and over a long period of time. And it was huge. It was a huge database. So back in those days, it wasn't something you would use MySQL for. Apple was a big thing at the time. It's only gotten bigger. So you put your serious issues in there during project development so that you can keep track of what's working and what is not and how you fix things. And that part is the critical to the story. So the database was used over the development lifecycle of all hardware and software products. So if you were making something at Apple, it was in the bug database so people could keep track of development progress and features and which features were broken and all that. And so Apple, like so many companies back then, would start off a project with a code name or code names, and then they would transition to product names. So this is problematic for people, especially as I was a contractor. So I was only there for I was there for a total of, I think, 15 months. And what they lacked, and this could probably have been generated somehow. Certainly somebody who had this knowledge could generate it from the database itself. And it could have been a useful tidbit of information. But the code, okay, so part of what you would fill in when you're creating a bug, you'd say, oh, here's the issue, and here's the project. And the project could be, and I'll use Power Mac examples, but there were so many. So the project could have been PDM. PDM was a code name for the Power Mac 6100. It was a flat, weird, it was a very odd-shaped computer from an Apple product line sense. Very different from what they shipped otherwise. But anyway, the PDM, codename PDM, eventually Power Mac 6100. Well, that's all well and good until the product gets an official name. So where before I was typing, or I would select, what was I selecting? I think I typed it in. Because to have code names and product names in like a drop-down menu would have been insane. But maybe they did. I can't remember now. But so, PDM, okay. But it's at some point when the product is named, you would type in Power Mac 6100. The problem with that is that if I don't know, if I join the party later I wouldn't really know that it was the PDM. Although in this case it became famous because of the lawsuit from from Carl Sagan. So it's not always easy to look up older product issues if they were tagged with the code name. So if I'm working on PowerMax 6100 and I need to look up old issues to see if there's something called a regression where, oh, something has come back. It was fixed, but now it has returned and it's a problem once again. So you would search and see if there were any similar issues from previous development iterations. But you would have to know that PowerMax 6100 was also called PDM. You'd also have to know that the other products in the original PowerMac line were Carl Sagan and Cold Fusion. So PDM would keep its name until it became a product. So PDM to PowerMac 6100. Carl Sagan, and Cold Fusion was a thing. So the lawsuit, by the way, is a little trivia, not part of the real story. Carl Sagan, the entity, the business entity of Carl Sagan anyway, was not pleased that his name was being used as a code name, especially because the theme of the three products were things that are made up, I guess you could say. PDM was pre-Dennis Man, and Cold Fusion is, a hoax. So PDM turned out to be not necessarily the missing link and all this other stuff. So there were some problems. And so they renamed, so a second code name, and I don't know if this happened too often, but a second code name was assigned to what would be the PowerMac 7100, and it was BHA for Butthead Astronomer. And they couldn't use that also. So then the BHA was renamed to Law, L-A-W, Law. So as the saying goes, you cannot call Carl Sagan BHA, it's the law. So a little bit of humor back then. Anyway, so that's a bunch of code names, and then there's some history behind the code name. There was an Ethernet card called the John Galt. So that's always that kind of stuff creeps into everything. Since we were testing compatibility across existing products for the PowerMac case with the new processor platform, this was important because you would have to look up the John Galt card, for example, if you were trying to attach it to or insert it into a PowerMac 6100 or a PDM, whatever you were calling it. But then you'd have to know that it used to be called the John Galt card, even though it was like the Apple Ethernet 150 or whatever they called it back then. So familiarity was essential, but that was never really transparent. So if you had contract workers, as I was, coming through, even though I was doing technical work, but I was not there with the company for a decade. So I didn't have any sort of background history or tribal knowledge or anything like this. But the big problem would creep in. So the PowerMac transition project was huge, right? They hired tons of contractors. They were just, hopefully people knew what they were doing. Some did, some didn't. So the big thing was interpreting the report data so they would figure out how well they're doing. Because if your product is getting worse, that's bad. If your product is improving over the development cycle, that's a good thing, right? So you want to see fewer bugs, fewer new bugs opened, fewer regressions. You want to see bugs closing, right? That means they're fixed. So if you're adding fewer bugs, but you still have 1 million bugs, that's a problem. So I'll try to say this clearly because it's actually quite not funny, haha, but funny like, ooh, this is what happens when people don't know exactly what they're looking at. They don't understand the tools and what it's telling them. So the Aardvark project had this user interface that looked like a web page, but it was an application, and you would tell it to say, for example, show me new bugs opened since some date, right? You could see for the PDM and for the Carl Sagan or BHA or the law and the Cold Fusion projects. And you could have a report that said, oh, here's the total number of new bugs. And then you could say, well, show me the total number of closed bugs for that same period. And then you would know what the net number of bugs was. So we found this many new problems, but we solved this many previous problems. So then you can get like a trend line that says, oh, if you're adding more bugs than you're closing, again, then you're like, ooh, why is this happening? If you're closing more bugs than you're adding, that usually means, oh, okay, so we're getting closer to a functional version 1 product. There's some argument about whether Apple is really capable of that, but a version 1 product that you could actually ship and with some reasonable confidence. So at some point, someone ran this report and it said, oh, the number of new bugs is equal to the number of closed bugs over some period of time. I don't know if it was weekly, I can't remember. So they showed this graph of how the net bug growth was a line going up and to the right. And then it kind of leveled off just recently. And they said, oh, look at that. The total number of bugs is about this, the net number of bugs is 0. The net number of new bugs. So they're adding new bugs, gross, right? And then they're closing bugs. So we've reached bug parity. And so one would think, oh, okay, so that's on our way to closing more bugs than opening, right? We're finding fewer problems and we're closing more problems, or fixing more problems. We're addressing them. How about that? So that's all well and good. So there was an internal announcement, and there was also, oh, look at this, we're actually getting closer to, oh, we're going to show, yeah, that's awesome. And then someone pointed out that when you run the report in Aardvark, it gives you the first 10,000, I think it was, or some big number. But then you have to ask for the second page. So somehow when they built this report query, so whatever they were running, because you don't type in all this stuff over and over again. You have, I don't know if Sybase used SQL, but you'd have a query or you'd have a report defined that said, do these things, but it didn't account for the paging process. So somehow, so this leads me to believe that maybe they were doing it manually, but either way, this really did happen because they had to walk back everything, all the announcements. So what was happening was Sybase would return, oh no, you know what it was? I think it was when they ran the report, the results would be a table or it'd be a result set. And I think they saw that it was a 10,000 net, right? Like, oh, opens, closes, we have 10,000 bugs. So we're staying at 10,000. So, because this couldn't have happened early, because surely there were 10,000 bugs very, very soon. But the bottom line is this: they didn't know that you had to page through your results. So when you say, oh, okay, show me page 2. So the net bugs opened and closed was still a very large number. So in other words, we were not close to bug parity. But because somebody who was using this tool didn't know about this, they ended up declaring that we're closing and opening by saying, yay. And there was a big internal announcement and everybody was very happy until somebody said, wait a minute, you have to show page 2 and 3 or whatever. So it turns out there are many more new bugs than bug closures that they completely missed. And the take home is that you kind of have to understand the tools. It's like reading a speedometer and not knowing that it's actually the tachometer, right? Hey, we're going 7. And it says we can do 15 in a school zone, so we're only going half as fast. No, that's not how that works. So that was sort of humorous. I don't know if anybody got fired or anything for it, although hopefully they were not doing data analysis for much longer. Know the tools. Anyway, various companies had different bug database platforms. Jira has been very popular in recent years from Atlassian. Jira named for Gojira, the Godzilla, as some might say. So Jira is popular, and it's not great, but it is popular. Some were pretty bad, and some were fine. I've come across both of those and a few others. This is where the extent of my detailed exposure to databases as a tool fit into the QA process that I was a part of earlier and development later in my first tour. So I would use these databases as a tester earlier and then as a developer later. And the bug database is where you synchronize your communication. So, hey, I'm testing the product and I found a problem. So I'm going to write about the problem in a way that you can find it on the developer side or the project manager side and whatnot. And then as a developer, I would say, oh, okay, this bug has been assigned to me. And then I would add some information like, oh, here's what I've identified and here's the problem and I have fixed it, quote unquote fixed it. And then you reassign the bug to the person that found it so that they can check to make sure it's fixed. You try to do that because the person that found it, for two main reasons. One, they probably have a setup and they know what they did. so they don't have to try to read instructions and assemble a test setup to reproduce the original bug and make sure it's been fixed and whatnot. And then the second thing is there's a certain sense of ownership when you create, oh, I found this issue, it's my bug. Did they fix my bug? Right. So that ownership, there's a certain amount of attention paid to the thing that's yours. So if this is somebody else's bug, quote unquote, then they would think, oh, now I got to go get the parts to I got to attach a John Galt card to a PDM and then turn it on and turn it off, or, whatever the steps are. So the familiarity of the original bug finder plus the motivation to make sure that it's actually closed. They didn't close my bug. They didn't fix it. So good times. And as a developer, it's always useful because you as a developer do not have that my bug sense. You have, this is just more stuff I have to fix. I'm trying to complete the project, not deal with all these bugs from these annoying testers. That's unfortunate, but that's often what you run into. All right. So I was off to Phoenix, August of 2001, perfect timing. And then the job market took a bit of a turn, a little change a bit, if you remember. And if you don't, because it was a long time ago now, people from September of 2001 are about to turn 25. So it's the way it is. So that's what's up. So I was looking around for what I was going to do next in the Phoenix job market, which was decidedly not Silicon Valley. Although today it's a little bit closer, but it was not a great time, to be honest. A friend of mine from my Apple days, he used to sit one cube over, Jim K. And as luck would have it, Jim K shared his cubicle with Jim V. So it was Jim K, Jim V. Jim K was working at all of the places in Chico, California, because he too had given up on Silicon Valley. So he moved to Chico, and Chico was also not Silicon Valley, but it was close. So there were a few different tech companies, and they were all really close together. So he described it as they're all on the same street, but I don't know if that's true. But there were not so many of these tech companies. So he was kind of making the rounds as anybody, oh, you're a tech person from Silicon Valley? Step this way. With his background, he could do a lot of different things. And at some point he was working someplace that was doing some Oracle database based product development. So they were using the Oracle database for whatever it is they were working on. I can't remember what they were actually building. I know eventually he would work at like home improvement parts company. Imagine a Home Depot, but online. So you could get any product, like any faucet, any towel rack, any flooring, anything. So pretty cool. But this was, I think, before that. So because he eventually became the database guy, but the database was in their case, and this is actually relevant. So stick with me. The database was running on a machine that everybody on the team had root access to. They had admin access if you're a Windows person. So they had total control of the machine, and that would be a problem sometimes. He told me one day, yeah, everybody just logs in as root to the same computer. Like, what? That's insanity. And then everybody also had administrator or super user access to the Oracle database. Now, if you have root access, that's already ridiculous, but to add insult to injury, everybody working on the database has the ability to do anything, not only with the database, but with the underlying server platform. So that's just crazy. But it's important because more than once, someone would break the database because they did not know what they were doing. And they had, you've heard the expression, a clown with a monkey with a machine gun or a clown with a flamethrower. I think those are the two. Like you gave them full access and they wandered around saying, I don't know what I'm doing. And they clicked on things, whatever. That's not how you want to work things. There was, though, a database administrator called the Oracle guy. That's what they called him around the office, apparently. And when Jim Kay and I were having conversations about the Oracle guy, he said, yeah, the Oracle guy doesn't really know much. He's the Oracle guy, but I don't know if he's ever actually used the product. So we came to call him the OGMA, or the Oracle guy, my butt. Keeping it clean. OGMA, O-G-M-A. Anyway, OGMA did not seem to know what was going on at all. So we set out to teach ourselves, Jim Kay and Chico and myself in Phoenix, set out to teach ourselves how database worked so that we would know how to avoid the problems he was running into with his inexperienced and maybe incapable, certainly incompetent coworkers. Like, you should really know how anyway, doesn't matter. I did not have access to an Oracle database myself, so I selected PostgreSQL. I think it was version 7.4 back then, maybe. The useful thing, Postgres was mostly SQL compliant. That's, I think consensus is that stands for Structured Query Language, SQL. I'm not even going to verify it because I think some people think it stands for something else. Whatever, SQL. It was mostly SQL compliant. So the standard, I can't remember which standard it was, SQL 88 or 9 or 89 or something, or is that Fortran? I can't remember. So we could try some ideas out across the two platforms, and we would be able to have at least a usable amount of feature parity, right? Like if Oracle used something complete, and arguably they have TSQL or PSQL, and Postgres has PostgreSQL, but they're close enough that we could actually try some things like stored procedures and, well, Postgres has stored procedures now, but stored functions to do some database manipulation, and schema descriptions were similar. You could have namespaces, all that. So the bottom line was PostgreSQL was for free for me, open source database, was good enough for me to try some ideas. At the same time, Jim Kay was using a more expensive, not free Oracle database. Jim Kay had super user admin access, as did everyone else. I don't know if Oracle calls it something else, but he had unblocked, complete and total access to the server. So we could try out ideas all day, and that's what we did. So the learning was taking place, my discovery of PostgreSQL, So remember, we had everybody in his team accessing the database with full access to everything. At least once, that I remember, someone actually dropped the database, which is as bad as it sounds. Drop in SQL means remove from database. You can do it with a table, for example, drop table, you can drop function, etc., etc. A row in a table can be deleted, but if you want to delete the whole table, you say drop. A table is dropped, and an entire database can also be dropped. So if you delete a row and you drop a table, and you can also drop a database, well, that can be catastrophic, because the super admin root user or whatever, you don't get a whole, are you sure you want to do this? Are you really sure? It just does what you tell it to do. So you drop a database and it's gone. That can be catastrophic if there was no backup, for example. And it is an indication of a systemic issue, at least, that why are you letting people drop the database? That should be the hardest thing to do. Because that's sort of, you could be deleting your whole company. So, but this could also occur if somebody, I'm just going to drop this database. Well, you typed the wrong name. I'm sorry, you drop a table. You dropped the wrong table, so now you still disconnected our, customer workflow with the data behind it. Now we have to restore that from backups, which may or may not be current. A little water break. So yeah, these are the sorts of things you don't want to do in a production database. You can do that in your testing, but dropping data and these are things you want to work through and test before you roll them out to everyone. So lessons learned by some, but not by all. So we explored some interesting features that were not so popular with the new kids and their object relational mappers, which I'll get to what that means later. But suffice to say that we started looking at the problems Jim Kay was running into as a way to learn the most vulnerable parts of a database management system, of database management as a practice, so we could address them in our experiments. So I'm not going to get too nerdy here, but we established a few ground rules for implementing that we implemented in the database to address these problems and to make the database consistently accessible from client software. I have a funny salon story about this, which I'll get to in a second. I hope I get to it. I don't know if I wrote it down. And we presumed the use of views and indirect access to tables and table data, for example, and then not everyone should be the super user, so you cannot drop data. We had a no delete policy, so you, rather than deleting data from tables, you would mark it as deleted, so that way it was still there, so you could undelete it if you needed to. There are cases where you need to delete data, like personally identifying information. You need to actually remove it from the database if asked to do so. But in other cases, if you deleted something and then you could not undo that, that was to back up and restore. But if you marked something as deleted and then you could delete it like a purge later, like, okay, let's gather up all the deleted rows and delete them all at the same time, after you've had a moment to say, these are definitely going to be deleted, right? We don't want to go back. Okay. And this is where you'll see sometimes, oh, if you can mark your account deleted and you'll have 30 days to undo that. Like that's kind of the idea with that is you want to make sure, you want to make double sure that you're deleting something. You don't want it to, oh no, I didn't mean to do that. Not a problem. We didn't actually delete it. Sometimes you have to wonder, well, can I delete my data? And some companies will tell you, well, no, not really. So not getting nerdy. Jim's team could go to town on their database and nobody quite knew what they were doing, much less what their fellow developers were trying to do, which was a bad thing. We were designing for a database that was hidden behind some access controls, defined views, and explicit storage function access, and more. So we basically made a database server platform that would protect the developers from themselves. Drop database. Oh, you don't have permission to do that. What? Yeah, you only have certain permissions because you are no longer the super user. So that's just fundamentals. But accessing tables through defined interfaces, so you couldn't randomly say, oh, I'm going to add a new column to this database, this table. Like what? You can't just go changing data models. There has to be some sort of thinking that goes into it. So that's what we pursued. And namespaces, so there were no naming collisions, implemented as schema, and so on. Eventually, I would head back to Silicon Valley for my second tour. I started working on a project for Salon.com while I was still in Phoenix, and I would eventually move there to work in San Francisco. So that was how I moved back to the Bay Area for my second tour, was Salon.com. And as it happens, the thing I was working on was using PostgreSQL, or it might have been the fact that I wanted to use PostgreSQL. I can't remember who made that decision. Though as I would discover, mostly when I started working there, they had Oracle and MySQL databases also, which all did different things, which was my first lesson that sometimes organizations just grow and change without a plan. And so you get different systems that sometimes need to share data. And that was interesting. I used what I learned in my time in Phoenix, working with Jim Kay and our remote experimentation. And I learned two things in my Salon days. Salon had the same basic idea about some of their systems where people had direct modify access to things like the subscriber database, which was in MySQL, which meant the person who was sort of customer support and subscriber support. So she would get contacted all, hey, my subscription is this, and somebody gave me a gift subscription and it's this and that and whatever. The subscriber database was eventually a huge mess with a variety of data consistency problems because that person was using a tool called PHP MySQL, which was raw database access. You could add and remove columns. You could change values of things. You could break foreign key relationships. So the relational database, the relational part is important. And if you don't know what you're doing, you could break all this stuff. So eventually there were just these huge questions like, how many subscribers do we have? And the answer to that question was a mess. So this was a direct practical example of why our design considerations were actually sensible. No, you should not be able to just willy-nilly modify things. That'd be like saying, hey, 4-year-old toddler, you're learning how to write? Well, here's the checkbook. Just start writing in it wherever you want. Change numbers around, whatever you feel like. It's lunacy. But I was able to see firsthand, like, dude, this is a problem. And to give you some idea, Salon was a public company at the time. And I don't know if they still are, actually. So Salon being a public company, they had to file their quarterlies, their 10Q reports. And part of the information in there was how many subscribers they had, because that was recurring revenue and all this stuff. So making this a mess had material consequences in government filings for this public company with real investors and so on. So something to think about. I was new at this myself, and this was my first production database design experience. So while I applied our various learnings, named schema for data isolation, views, stored functions, wrapping table modifications, etc., I did not really have the notion developed yet that a database is it's going to need to last, or at least be sort of easy to modify over time. So the data itself could be modified, pardon me. But I mean, that's the database keeps track of that, the data. But the design of the database itself, those columns I mentioned, you might need to have like a subscription start date and an end date, and keep track of any modifications or extensions. And later you might say, oh, now we have a different kind of subscription. So we have to have a differentiation between the old kind and the new kind. And so you may need to modify some things about how the data is organized, and so on and so on and so on. This is where being an architect is a really useful skill on top of engineering and coding and all the other things. And being a database architect is not something you just snap your fingers and label yourself, just like the Oracle guy of old. So I was learning that, I have more to learn. I have more practicality to learn, like real problems mapping to databases. Sounds like, oh, whatever. But later you will find like, oh, I really need to know what this relationship is between these two namespaces or schema. So I need to have a way of relating these two things that are explicitly kept apart from each other in these different namespaces. So sometimes you have to be creative, but the best way to consider these things is what will happen from 10 years from now if somebody is looking at this design and they don't have the insights that I have now in the design part, so that they can say, oh yeah, this makes sense. I can see where you would need to create this relationship for this reason, and so on. So a database is supposed to be, there's a term called single source of truth or source of truth. So you should be able to rely on the database being correct. Maintain the invariant, as Bjorn Strustrup would say of classes. So maintain the invariant, the data should always be right. It should be difficult to make it wrong. And that was the design philosophy, but practical implementation of that takes practice and trying out ideas and so on. So I learned quite a bit from Salon, even though I didn't really like working there. We did have an Oracle database to look at, so that was interesting. The version of the Oracle database they were using was like as old as the company, because they never really changed it. So it was at least 10 years old. It was a long since out of support from Oracle, and they didn't pay for a license anyway, so whatever. It's where the content of the Salon online magazine was stored in this Oracle database, and had been stored over most, if not all, of its 10-year life to that time. I think they were 10 years public, and they may have been around before that. And Salon had started with this thing called bricolage, which was a Perl-based tool that would store its data in a Postgres database. So there you go. Long since gone, right? Bricolage was no longer the platform of choice, although there still was some Perl legacy code floating around. There was Java code, there was PHP code, there was probably other tools, random queries being run here and there. And the design of the Oracle database was only barely known. There was a coffee-stained printout of the database schema across like two legal-sized pieces of paper taped together or something. I don't know why the design itself, the source of the design, the original data model description was not accessible for some reason. Not sure why. So we knew how it worked, and that was informative. But for whatever reason, there was no explicit design source to examine. So it was always a little bit dodgy if you wanted to modify the content database. Anyway, the entire Salon experience was useful from a practical database design perspective, at least. Yeah, I don't know. It was a total mess. And I will say, a little bonus practical learning. So I was rewriting some of the system database for the subscribers and keeping track of some revenue streams and whatnot. And so one day someone from accounting came over to me and said, I run these two reports. One is like a weekly and one's a monthly, like month end. So the weekly numbers aren't adding up to the month number. And it was like new subscribers per week or something like that. So So I looked into it, and the problem, which was a classic, because anyone could write any query at any time against anything in any database. So this was similar to the Jim Kay workplace setup. People had written different queries in different ways to perform these two operations, which they should basically be similar, right? I want you to show me the data from the last 7 days, and then I want to I want you to show me the exact same data from the last 30 days or the last month, right? like even accounting for 30 versus 31 versus 28 days is something the database can do, but they didn't really account. They didn't account for anything. So the person in accounting said, yeah, we get different numbers that don't add up. That seems bad. I said, yeah, it is. So I was having conversations with them about, do you want midnight to midnight, like midnight on the first of the month to midnight at the end of the month? Do you want it to be 12 midnight plus 1 second? Right? This seems like overkill, but at the end of the day, if you have a consistent defined platform and you know exactly what you're looking for, just like that bug database problem, you can avoid that, right? Because you know ahead of time, 10,000 per page, I want to make sure I get all the pages. You're having subscribers per week and it's not adding up to per month. Why is that? Because whoever wrote these different queries that run at different times and whatnot was not using some sort of standard database design principles. Like, you really don't run time-based queries in what's called now, right? So you supply explicit time, start and end. Like, don't tell me how many entries there are now for the last month. Show me the number of total entries between start date and end date. Right? It could be the first day of the month too, but don't do now. Do an explicit end date. Like, give me a fixed time interval. Because if you run something now and then you get, just very briefly, if you run a database query now, but something is added to the database after you ran it, but before the time interval ends for whatever reason, and if you're really sloppy, that can happen, then later your week number for the second week of the month or whatever will not include a couple of entries. And then when you run the month number, they probably will be included. So now you'll see an inconsistency in the data report sums. So these are the subtleties, though, that you can take care of if, for example, you define a data view in the database and it's there in one place that everybody can see and they can see it's documented and here's how it works and here's what it's supposed to do. And you just say, give me a start date and an end date and a total number. And you should be able to run this database query between for a weekly and a monthly report, right? Start date, end date should be appropriate for that. And so if you document these things, you have them in one place and you don't allow people to just go, I'm going to write my own query and not do it correctly. You'll get more consistent data and you'll have fewer people making silly mistakes. And in this case, it was a read problem. Like, you're reading the data incorrectly. It's not working, but you don't know it's not working. But, imagine if these people were starting to write things, changing the database, as was the case with that PHP MySQL thing. Total nightmare if you let people just go wandering around changing values. It is insanity. If you're a pedantic database person, you're probably already crazy. So I left Salon eventually. The commute killed me, but so did the workplace. So I was still doing hardware, but more databases also. So I was still working on hardware. I would eventually work at Palm when they were working on the Pre and Pixie cell phones. That's where I had some intense exposure to Jira. It's a fine tool. It's not great, but there are some things that it can do that are useful. And at Jawbone, I was working on audio manufacturing analytics and audio device calibration. So there was a different sort of data capture to store in a database. But the job market in the post 9/11 days was still a little bit wonky. So I moved back in 2005. We had the Great Recession coming up a few years after my return. So I was trying to branch out a little bit. So hardware is hard. Since I was still gaining familiarity with PostgreSQL, everything I was doing that needed a database was, as luck would have it, based on PostgreSQL. That's convenient. Well, there was not AWS or Azure Cloud back then, or Google Compute or whatever they call that. There was easy static IP address leasing for home networks. So you just basically have the same address all the time. So you could use your home network exposed directly to the internet as your own little cloud. So I had my personal server connected to the internet all the time, and I could build stuff and try it out directly, which was even more convenient as mobile web browsing was becoming a thing for real. The iPhone would come out eventually. I had a BlackBerry, which was okay for web browsing. It was convenient to learn the differences between a desktop browser and a mobile browser at the time. Now your mobile browser is basically the same, except for the screen size, but it's, for all practical purposes, close enough that you don't have to worry quite as much. And someone somewhere will be like, are you serious? And I would simply say, no, I'm dramatically simplifying that. This is not about browsers. Probably the most interesting thing I did in this time frame was the regular DB, which was my internet movie database clone for service industry workers. So if you were a bartender, server, chef, door guy, door person, working in the service industry in Silicon Valley, this was a way to connect with your regulars before the notion of Facebook pages, so that people could be found by their regulars without sharing personal information as one does with Facebook friends. I don't use Facebook anymore, so who knows? But you would create a profile on the regular DB and you would share information like, oh, I'm working this Thursday night or whatever. Just information related to interfacing with your regular customers at these places. What a horrible time. Facebook. Ugh. I was just thinking about that. Anyway, this would plant. This would plant some seeds for the Food Truck YP platform that may yet see the light of day as a differently named thing. Food Truck YP was the ultimate database project where I got about halfway to what I wanted to do with a standalone data model and functionality implementation for all the features I was looking for from that the data perspective. So in other words, I had a fully functional data model, which really showed me some of the corner and edge and whatever cases that like, oh, you know what, this could be a problem. I had too many foreign keys, for example. There was no practical reason to have so many foreign keys. But that's how you learn. So I had this whole data model, and I was nearing a point where I could actually launch like a version 0.9 beta of Food Truck YP. And then I had a house fire in April of 2013, and I moved to Vegas in July of 2013. So everything was kind of tabled for a while, if I can make an SQL joke. So now, let me come back to that ORM. Did I tell the story? I can't even remember what story I was going to tell. I can't remember. Well, you're probably getting tired of this topic anyway. ORMs and abstraction. So an ORM is an object relational mapper. It's in simple terms. If you are not a programmer at all, then an ORM, as they're called, is a way to interact with a database without being overly concerned with the database itself. So the structure of the data you want to describe is designed in the programming language of choice rather than in SQL itself, which includes tools to manipulate the database structure and design. So remember that drop command. Sort of like email, you can use an email client that you prefer. Maybe you like the Gmail client, maybe you like something else. You don't have to have any knowledge about how the underlying email server works. So if you're a developer or if you're just using email, you don't have to worry about whether you're using Gmail or Outlook or Yahoo or whatever. It all kind of works the same from your perspective, even though they're kind of different. So you're using the mail user agent to interact with the mail transfer agent and the mail delivery agent. So behind the scenes, all this stuff is all orchestrated for you. And then you don't have to worry about it. So an object relational mapper does something similar for a database so that as a programmer, you don't have to worry about how it works. This is not always a good thing. I have encountered people on technical projects who are overly concerned with not using features of some tools like a database server and even the entire feature set of a platform like AWS today. They don't want to be bound to these. Like, oh, if we depend on AWS, then we can't move to another platform. Just in case they want to change to something else, which means they would rather be portable than make use of the tools on hand. So, hey, like this will solve our problems if we use this AWS feature. No, we don't want to commit to AWS. Well, okay, it's going to take 10 times longer because they've already done the work. Database server as well. We don't want to use namespaces or schema. We don't want to use stored file because MySQL doesn't have, and you're like, well we're spending a lot of time trying to make sure that we don't have to spend a lot of time. So that becomes sort of counterproductive. So we don't want to be bound to these platforms just in case we want to move. So an object relational mapper can help to enable this sort of thing because you write your ORM so that it doesn't care if you're using Postgres or MySQL or something else. And then everybody's happy, except not really. And this doesn't really work. There was a NoSQL window So I myself became somewhat familiar with Mongo, and then I used CouchDB a lot more, and now there are vector databases and so on. By the way, it turns out Postgres over the years has evolved with all this. So you can do some NoSQL style document storage, create a document database. You can create vector databases and all that. So PostgreSQL really is the Swiss Army knife of sorts when it comes to this. And it works pretty well. It's pretty solid. But because people don't want to commit, they wouldn't want to use these tools. So they'd rather use, I don't even want to get into it anyway. So when you are not familiar with the tools and you want to keep it simple, you lose out on the functionality of the tools and the understanding or the ability to manipulate and use the tools optimally when you have that understanding. So if you're like, I don't want to understand it, then that's probably doing yourself and whatever you're working on a disservice. And to be honest, this sort of thinking, or lack of thinking sometimes, is only becoming more endemic. Deep understanding is something that will be left to some AI model, perhaps. Like, oh, I don't have to know how it works. I just tell whatever chat client to write me a database. But the database is written for the now based on training from some other projects. So you're going to get some version of something that seems to work. But again, think 10 years in the future, your model doesn't care about that. So you're going to have to do some forethought, and you're going to have to understand how to migrate your data if it comes to that. So letting AI do the work for you is not the best idea, in my opinion. So much thought goes into some tools, and so much thought can be directed towards how to best use them for a particular project or system. I think some people are becoming less interested in this amount of thinking for whatever reason. Lazy? Too complicated? I don't know. Which might be a problem someday if it isn't already. So 10 years ago, again, 10 years from now, I should say, someone will look at your database model for your company, and your company depends on it, and they'll say, I don't even understand this. We'll have to ask ChatGPT version 10 or whatever, Claude DB coder, and who knows what will happen. And it'll drop your database by accident. It'll drop your database accidentally because at the end of the day, it got trained on data from Jim Kay's company so many decades ago. And that's all I know. Anyway, PostgreSQL is a fascinating tool. It's something I've not spent quite enough time on, but we do have, as part of the Innovate for Vegas Foundation, we have our smart database component of the smart social system. Wait, social networking? No. Smart social is connecting data and people. So it doesn't have to be a Twitter feed or whatever. It's really about capturing data and making use of it in different ways, whether humans want to use it or for software modeling and so on. All things that have gotten a bad reputation more recently. But generally speaking, smart social is the connection of people and data, especially at city scale. So there's a database component that will prefer PostgreSQL and will make heavy use of all the notions I've described here, which I started learning back in 2002, 3, 4, somewhere in there. And it's a skill worth having, I think, if you are in this sort of stuff. And if you're not, none of this will have made sense to you, but that's okay, because at the end of the day, you're probably learning something that I don't understand, and then that's good. And keep it up. Don't hand that skill over to people who have no idea what they're doing. And don't you be that person either. That's where I'm going to leave it for today. Oh, just under an hour. Wow, I didn't think I would talk about this for so long. But nor did you, perhaps, although you saw the time, the duration of the episode before I did. Here we are. Thanks for listening, as always. Don't forget to check out buymeacoffee.com/Dan Hugo for links to all of my other audio programs, including this one. And check back infrequently to see if the Quaggling Sand or any of the other website deployments look nicer. One of these days I'll get to that, but I literally have the Smarter Smart City Challenge to try to get people involved with, which has been occupying too much of my time as I'm speaking right now. I should get back to my database schema design, but I really got to finish those website beautification projects first. Too many things to do. And so I will leave it there. Thank you, as always. Until next week. Bye-bye.